Hi, welcome to Data Platforms in the Age of AI, the next evolution of the data engineer. My name is Björn Olofsson, and I work as a data tech lead in Sweden. I worked 25 years in data and analytics and been working in a variety of companies, industries, projects, and experienced a lot of different challenges. I've seen the evolution of data engineering from ETL developers working in siloed data warehouses on-prem infrastructure, where different workloads needs to run at different time of day. So the ETL workflows were running at night, and the analytics workflows were running at day. And then if you were to run a hook query, it couldn't be bigger to disturb the analytic workflows. These projects usually had planned monthly or quarterly releases and took time to deliver value to the end users. And then we went into the big data Hadoop era with more focused on huge data volumes, scalable infrastructure, and streaming, ingestion, and stream analytics. In this era, we started embracing software development practices like Git and CI/CD. And at the latest modern data platform era, with modern cloud-based databases, a lot of SaaS application for everything like ELT tools, the cataloging tools, analytics tools, and so on. We had ELT patterns where workloads execute in the database and not on separate servers, and also a big focus on self-service analytics. And now we see the shift into the AI-augmented data engineer. So back in the 2000s, I spent night waiting for ETL jobs to finish. Today, I can spin up an ingestion pipeline in just a couple of seconds. That's a huge shift that's happened. So the big question, will AI take my job or just make it cooler? It's an exciting time we live in, and the data engineering role has already changed a lot due to AI, and will change even more when AI matures. At Solita, this is something that we track closely, and we have different work groups to follow up the trends and the tools. I'm leading an initiative in Sweden, and we do this to stay on top of the technology trends and to be able to recommend the right tools for our clients. And not just jump onto the latest, coolest technology or tool, but to actually see what delivers value that it promises. But let's get back. We have gone through a bunch of industry revolutions. We had the industrial revolution, where machine amplified muscles, and factory workers became machine operators. We had the internet revolution, when machines amplified communication, and office clerks became knowledge workers. And what we see now is the AI revolution, where machines amplify thinking. And data engineers, for example, are evolving into AI strategists and AI collaborators. Each of these eras created a fear of replacement, but in reality, it redefined roles, created new opportunity and new jobs, and there's nothing that doesn't say that it will be the same this time. At Solita, we have something that we call Solita Data Platform Architecture. I will not go into all the details on this now, but it handles all the aspects of a data platform. So it goes from taking data from data sources, ingesting it into some kind of structured storage, doing some transformation, enrichment, data quality controls on it, and then publish it for interaction by other tools. On top of that, we have a couple of governance layers. We have data governance, like setting data standards, defining KPI, implementing data catalogs. And we have the architecture governance. How does this fit into the overall enterprise architecture? And also setting up and defining our data products as data services. And in the bottom, we have cloud governance, scaling cloud infrastructure, monitoring, security, monitoring cost, and things like that. And on the left, we have like development and deployment, orchestration, CI/CD, and how we work with our data platform. But let's simplify it. So like we said, what we do is a data engineer pretty much build and maintain data pipelines, loading data from different sources into some kind of storage. And these sources, it might be files, cloud applications, core business system, or sensor data like IoT data. Usually we do this through either an integration platform or some streaming platform or through batch job, setting up jobs once a day or once an hour to ingest the data into the storage. When it's there, we clean the data, we model the data, we are applying business logic, and we are also ensure the data quality, that the data is documented, and that we have the lineage. And then some kind of data interaction happen. And it might be like reporting, analytics, or use the data in some AI use cases. So AI is already here. As a data engineer, most of us use AI in our work every day. It's in our way of working, like we're using Copilots to generate code, generate boilerplates for SQL, PySpark, Airflow DAGs, or using LLMs like ChatGPT and others for bouncing ID, generating drafts, getting second opinions, and so. But it's also in our tools. All the tool developers are really racing to implement best AI features now. And some already have them in the tools, like dbt that we work a lot with. It's a transformation and modeling tool. So they have like auto documentation and automatic lineage through AI. We have other tools like data observability tools like Monte Carlo, which is monitoring pipelines and trying to find anomalies in the data, like if a field starts to deteriorate or change characteristic over time, it will alert. And then in all of our data visualizations tools, they have some kind of chat with your data functionality, like Power BI Q&A, where a business user can ask, give me the latest month's sales compared to the month before, and we'll get a draft dashboard or just the insight that someone can continue building on. So this is just some examples, and there is a lot more. And here we have some examples of where AI is coming in the tools. So like I said, the ingestion pipeline is we're taking data from some source, ingesting it very raw into some kind of storage. We set it up with an interval, either it might be streaming or with batch interval. This is a very static job, and this is something that AI is very good at. And there are platforms. There is an integration platform we call that's called Vercato that we work a lot with. They are developing something called Workbot GPT, and it's like a conversational interface that allows users to build complex data pipelines, automations just through natural language. Another ingestion tool called Airbyte have a function called AI they are developing, where the end user instantly can build connectors, map schemas, and spin up pipelines, also through natural speech. If we look at the storage and transformation layer, when we land the data, what we usually do, we land it raw in the database, and then we start to clean it through some kind of layers like bronze, silver, gold setup. We start with deduplication, fixing broken records, and so on. And this is a task that AI managed very well. But then we start applying business rules and model the data to business-ready data set. And this is probably where I have the hardest time. So the modeling is for now a very valuable knowledge for us humans. So So here we have some tool. We have DBT, like I said, it's a transformation and modeling tool. So they are developing the DBT Copilot, which is like an AI modeling partner, suggesting definitions, writing test cases, and exploring metrics, or at least help you explore metrics. And then Snowflake, which is a data platform. Snowflake has a lot of AI functionality being developed. But one thing that I think is very interesting is the Snowflake Cortex AI SQL, which already delivered. And it helps you transform SQL into be able to call LLM functional directly from the SQL inline. So it might be like you want to translate a product description. So then you just use a translate function in the SQL and translate it from English to the end user's natural language. But that's not all. I mean, since you can access LLM and you can point out which model you want to use, you can pretty much do everything another LLM can do. So what you can do is you can send in all the characteristics of a product into the SQL, into the function, and then let the LLM create a summary of this product, for instance, that you can then write to another table. For the information interaction, there are tools. We have like Tableau Next. Tableau is developing an agentic tool to deliver intelligence and context awareness to the end users, so that an analyst can reason with the tool and get insights and recommendations directly. And also another example is Databricks AgentBricks. So that's a platform for deploying AI agents to handle feature engineering, workflow automation, and things on top of your data. So this, like I said, just example, but here is where it gets really interesting. Some vendors really aim at rebuild how we work with data and not just to augment it. So we have, for instance, Google Cloud AI agents and Matilda and Maya. They are aiming to create virtual teammates to handle many of the manual tasks that data engineer does today. So the plan here is to have a set of AI agents cooperating with each other and with human oversight that orchestrated work. So what you should have is, if you have a team of 3 or 5 data engineers, then you can spin up like a bunch of AI agents to augment these developers with some of the more mundane tasks. So there might be pipeline agents to build, test, and maintain data pipelines through natural language, or you can have a data quality assurance agent to continuously monitor and check the data to enforce data quality and consistency. Or an operation agent that spot issues before they break SLA and fix them. It might be scaling infrastructure, or it might be renegotiating contracts that has broken. They also have like an analyst agent to prepare a first draft for a business user, so that a data engineer or analytics engineer can continue work on that. So imagine a pipeline that notices a schema change during the weekend, and by the time you check Slack on Monday morning, it has already renegotiated the contract, remodeled the data, updated the pipelines, updated the logic and reloaded the data, and everything is fixed when you come on Monday morning. And this is the promise of the agentic data engineer. It's not really there yet, but it's in progress. So what will happen tomorrow? What will a data engineer do tomorrow? So we have, say, less plumbing and more value. So AI handles 80% of the scaffolding, and the data engineers reviews and defines contract, setting up quality rules, governance, semantics, and so on. We also see the rise of the prompt engineer data edition. So it maybe not prompt engineer, more context engineer is more appropriate. But the focus is to translate messy human needs to AI-compatible tasks, so that the AI agents can act on that. We also see citizen data engineers, so business users that need a new data set added to the analysis can, by themselves, by natural language, set up a new pipeline, get the data from an API into the source, model the data, schedule it. Of course, with the overseeing of a data engineer that will verify it and merge it to production. AI will also become a data consumer. So the data engineer's job will be to enable AI agents to query, monitor, summarize, and act autonomously on the data. And last but not least, we see that data mesh will evolve into AI mesh with intelligent data products, renegotiating contracts, scaling infrastructure, and publishing metrics. So, with all this said, should we be worried? I said yes. If we ignore it, we will fall behind. But no, because AI isn't here to replace us. It's here to be a junior developer. It's fast, it's tireless, it still needs oversight. But in the future, a data engineer may not write the most code, but they will know which AI to use and when to use it. So, key skills. Knowing what to build and not just how to build it. And knowing when to use AI and which models to use and trust. And now knowing how to communicate with AI. So, in summary, AI will handle boilerplates, data engineers will review and refine. There will be more focus on guiding architecture choices, not just building them. Ensuring trust and explainability in the data and in the AI models we use. So business can trust the data enough to take decisions on it. And aligning the data with business outcome. And that means not just moving and cleaning data, but making sure that we deliver actual answers to the question the business is asking. Like improving customer experience, reducing cost, spotting new revenue opportunities. So what do we do now? Use the AI functionality in the tools and learn how to communicate with AI. Even if it's not perfect yet, it will mature. So to stay relevant, we need to learn to work with this. And like I said, the tools are not perfect yet, but start working with it, start learn to context engineering, start learn to communicate with AI. Think of it this way. In 2025, your career booster was if you knew Informatica. Sorry, in 2005. In 2015, it was Hadoop or Kafka. And in 2026, it will be knowing how to work with AI, how to guide it, trust it, and get value from it. Thank you. Hope this was interesting for you. If you have questions or you want to discuss, please reach out to me. These are 2 links to my 2 crash courses that are around modern data platforms. If you scan the QR code, you can follow it. It's a part 1 and part 2. Hope you enjoyed the session. Thank you.